Finding the cure for cancer is proving more complex than getting humans to Mars. In all these decades, billions of euros have been spent on cancer research, but no definitive cure has yet been found. How is it possible? Let's see what are the answers that the experts have given. Let's start by saying that in the 1970s, only 25% of people with cancer survived 10 years or more after diagnosis. Today, that figure has risen to 50%. Thanks to the tireless work of researchers, doctors now have more tools at their disposal to fight cancer. Cancer is the second leading cause of death globally after cardiovascular disease and is more prevalent in rich or developed countries than in poor or developing countries. Worldwide, 1 in 5 people will develop cancer in their lifetime. To understand why cancer is not yet cured, we need to start from what it is. The term cancer refers to any mass that grows from uncontrolled cell division and has the potential to metastasize, that is, to invade or spread to other parts of the body. Carcinogenesis, which is the process that transforms normal cells into cancerous cells, occurs due to a mutation in the genetic material of normal cells, which thus begin to grow out of control and are free to replicate, leading to rapid tumor growth. Why haven't we cured cancer yet? First reason. First of all, it is imprecise to speak of cancer in the singular, because it is not a specific disease, but a generic term that indicates more than 200 distinct diseases, categorized according to the organ, such as the lung, breast, colon, and prostate, or the type of cells from which they derive. Cancer arises from our own cells, so each malignancy can be different, just like people are. Each type of cancer, in turn, has many subtypes, each with a different appearance and behavior, precisely because they are different on a genetic and molecular level. In this way, the hundreds of different diseases become thousands. There will never be a single cure for all types of cancer. Unfortunately, cancer is not like an infection, in which once the bacterium is eliminated with the antibiotic, it is cured. It is something much more complex from the biological point of view, which does not come from the outside but belongs to us. Second reason. Cancer cells are not static, but evolve over time, and sometimes become resistant to therapies that initially proved effective. Cancer cells are crafty and are always developing new strategies to escape the careful control of the immune system. Each cancer results from a series of mutations, and as the tumor mass grows, more and more mutations accumulate, which can lead cancer cells to develop resistance to a treatment over time, rendering it ineffective. For this reason, they may no longer respond to chemotherapy drugs or radiotherapy treatments given initially. Cancer is a complex and evolving set of diseases, which are unlikely to allow a single definitive cure to be found. Third reason. Let's take 2 women, both with breast cancer, and compare the 2 malignancies. Dozens of mutations will be found, but only a very small number will be identical between the 2 individuals. This means that by attacking that breast cancer with the exact same therapy, one patient could be cured and the other die. A drug that might work on one cancer patient might have absolutely no effect on another. Each tumor, even of the same type, can behave differently in each patient. This enormous variability is responsible for the difficulty in curing cancer. Furthermore, not all cancer cells will have the same genetic mutations as neighboring ones. This means that treatments can often kill one type of cell in a cancer, while others can survive the treatment, allowing the malignant tumor to continue growing. Even the same type of cancer in different parts of the body can respond differently to medications. Fourth reason. It takes several years to develop a new drug, and many more for its subsequent entry into the clinic. Scientific studies to determine the safety and efficacy of new anti-cancer drugs require many years of experimentation. The current genetic and molecular knowledge speed up the laboratory part and allow to shorten the time, but it takes years before a new drug obtains approval for use in patients. Over the past 40 years, research has made astonishing progress, thanks to an ever deeper understanding of the biology of cancer. Survival rates for many types of malignant tumors have thus increased significantly in recent decades. Prevention is the best weapon to defeat cancer, because detecting it in the early stages means being able to fight it in time and increase the chances of survival. More than 9 out of 10 patients with diagnostic breast cancer survive for more than 5 years if it comes in the early stages, while it drops to 15% if the cancer is in the more advanced stages. To make cancer more and more curable, it is necessary to continue investing in the best scientific research in order to develop new treatments suitable for the treatment of all the different types of cancer. A myth we often hear is that there is already a cure for cancer, but for some reason it is being hidden from the public. For some, it is a conspiracy. For others, the fault lies with the pharmaceutical companies who want to hide the cure in order to continue to profit from anti-cancer drugs. But is it really so? It is one of the many conspiracy theories that have been circulating on the internet for years, garnering a lot of support, but which is without foundation. The pharmaceutical companies themselves invest billions in the development of new drugs. If one of them found the cure for cancer, why would she keep spending all that money? As a result, medical research has made important strides and made cancer considerably more treatable than a few years ago. And second, think of the huge amount of people involved in the research and production of anti-cancer drugs. How could all those people keep such a secret all these years? In 2016, David Robert Grimes, science writer and physicist at Oxford University, published a study in which he tried to calculate the probability that a conspiracy theory would be revealed by chance or by direct will. According to Grimes's calculations, if there was a hypothetical conspiracy by drug companies to hide a cure for cancer, at least about 714,000 conspirators around the world would have to be involved in order to keep it hidden. It would take about 3.2 years before the secret is revealed.